All right, here we're going to take a look at how the Schlieren system works. So right in front of me is a lamp that creates collimated light. That light reflects off of this mirror here, through the wind tunnel section, over to that mirror down there. And then let's come around here. It's going to go through a little knife edge and then off of this small black mirror right here. And then eventually it will shine onto this screen. And so if we take a look at what we see on the screen, we can see that we have a wedge model that's inside of the wind tunnel, and then I have taped to it a protractor. And what you need to make sure you do is, of course, you have to line up the leading edge in the middle of the protractor, and then you want to line up the 90-degree mark into a line which is parallel to the floor of the wind tunnel. The easiest way to do this is place the model at 0-degree angle of attack, and then you can line up the 90-degree mark with the center of the support shaft of the wedge. When the tunnel is run at a high Mach number, supersonic flow is going to produce an oblique shock wave. That oblique shock wave is going to form at the leading edge and then come off at some angle. What you're going to do is when your lab mate runs the tunnel, someone is going to stand looking at the screen and take a picture of the shock wave when it is formed. And then afterwards you can then see the shock and measure the angle with the protractor. The key thing to remember though is the protractor has to be lined up level with the floor of the wind tunnel. This becomes important when you place the model at an angle of attack. You can no longer use the shaft of the model to line up the 90-degree mark. Okay, so you have to try and make sure that this protractor doesn't move, and you still have to make sure you line up the leading edge to be in the center position here. Okay.